Hey there, welcome back to continuing our linear regression example between predicting the weight of infants from their age. So if you recall from the previous video, we constructed the linear regression equation where we get y hat with an intercept of 9.35 and a slope of 1.55. And so again, the idea here is we're estimating y, and if you recall, y here is the weight. And what we're using to try to estimate the weight is going to be their age measured in months. Okay, so just because we have a regression equation doesn't mean that this is the line we're supposed to use to make all of our estimates and predictions. So in the final part of chapter 10 in PSTAT 5a is this question of finding out, well, is my slope significant? And so what that means is comparing a slope to that of a line with slope 0. So if you consider the intuition behind it, our objective here, so what we have is we have age, and then we have weight. Our objective here is to find, is there a significant relationship between age and weight, specifically a linear one? So meaning as x gets bigger or smaller, is that going to influence the weight? Now, what we're going to compare it to is a line with slope equals 0. And so what does that line look like? Well, that's a horizontal line. And if you have a horizontal line, the suggestion here is as the age goes up or down, well, it has no impact on the weight because, again, it's not increasing or decreasing. And so that's the motivation behind section 10.2 in PSTAT 5a. So what we're going to do is we're going to construct a slope for construct a confidence interval for the slope. And what that confidence interval will do, if you recall from previous chapters, is it will give you a range of estimates that the slope could be. So here is our motivation. So if you recall, confidence intervals have the form of the estimate plus or minus the margin of error. And then each of the subsequent chapters, 6, 7, and 8, depending on what our parameter was, we would have different estimates and margin of error. So for chapter 10, if you're doing the confidence interval for the slope, well, the estimate of our slope was B1. And then we'll skip the derivation for PSTAT 5a. It's really beyond the scope of this course. And the book just gives you the formula, which is going to be a t-distribution times the standard error of the slope. Now, this is just one number right here that is usually given to you. So right here, the standard error of the slope given to you in the problem, well, that is SE for standard error, then subscript B1 to identify that it's the subscript, it's the standard error of your slope. And the one thing that is markedly different from your subsequent chapters is this t-distribution has degrees of freedom equal to n minus 2. So the simple part is for chapter 10, really, you're just shoving a bunch of numbers into a formula, but you do want to note that it takes the same form that we've seen throughout. So if we finish this example using the numbers from our data, the slope we have here is 1.55 that we figured out in the last video. Now I'm going to look up 95% with degrees of freedom n minus 2. If you recall here, we have 5 data points, so n is 5. Degrees of freedom will therefore be 3. And then I just look it up on my table here, and using the t-table, we get 3.182. And then the last part, the standard error of the slope. And for this class, again, this will be given to you. And that's it. And so now if I do my addition and subtraction, I will get the endpoint, which looks to be negative 0.238, all the way up to 3.382. And again, the incentive is to see, well, could the slope be 0? And so yes, right? Because the lower bound is negative, the upper bound is positive. So we're saying because the data set's so small, I've only got 5 data points here, 5 infants, there's going to be huge variability in our estimate of the true slope. And that's the ultimate goal. So, well, what is the true slope between age and weight for infants? Well, from our data, we're suggesting it's any number in this window, which means it could. So the slope here could be 0. We don't know that it is, it might not be, but the estimate suggests that it could be. And since it can be, and if you look at this picture that we started with, the motivation behind this, well, that means I potentially could have a regression equation that looks like a horizontal line, which ultimately concludes for me that the slope is not significant. So what that means for us is this regression equation, while you can use it to make estimates, right, and make predictions, since the slope is not significant, then those estimates and predictions wouldn't be reliable to you in a practical sense. And so that's all we're saying at the end of the day. You can always make estimates, you can always make predictions. It's just how valid are those estimates, predictions, how much data is backing it up. And so even though I can make predictions and estimates, since my slope is not significant, then ultimately I should not rely on those numbers to be useful. And that wraps up our regression example.